This is Geometry, Unit 7, Day 1. We're using proportions to solve geometric problems. Okay, our I can statement of the day is that I can solve a proportion. We're looking at the ratios. You have solved ratios for several different years in the past, perhaps back in elementary, definitely middle school and Algebra 1, and here again in geometry. If A and B are two numbers or quantities, and B can't be 0, because you can't have a fraction have a denominator of 0, then the ratio of A to B, that's one way it can be written as A to B with a colon. It can also, the most commonly, be written as a fraction, and that's the hint that the denominator can't be 0. When you have two fractions that equal each other, we have a proportion. The equation that states that two ratios are equal is a proportion. And you've worked with proportions a lot in the past. We'll do that here shortly. First thing we're going to do is look at how can we simplify. First thing you want to be sure is that your units are the same. In this case, our units are the same. And we notice that 4 goes into both of these numbers. So 4 goes into this one 19 times, so 19 centimeters to 2 centimeters. Here we notice that the units are different, so you could either change the feet to inches and call it 48 inches, or you could call the inches feet. I typically like to make numbers smaller, not necessarily bigger, so I'm going to call this 2 feet. And I can of course divide both by 2, and I get 2 feet to 1 foot. Here we have 4 meters to 18 meters. It's a different way of writing it. Notice how the first way had a colon, the second way had a fraction, the third way has this word 2 in between. 4 to 18. It tells you how to set up your ratio. 4 over 18 is what that means. Here, the number that goes into both of them is the number 2. So we get 2 meters to 9 meters. And if the question is written with the word 2, then we should write our answer with 2. If it's written as a fraction, if it's written with a colon, and that tells you how you should write your answer. Here the units are different. So we know that 33 yards to 3 yards, because 9 feet is 3 yards. There's 3 feet in a yard. So here we're going to divide by 3. We get 11 yards to 1 yard. And since these are the ratios, we should actually write it with a 1. Okay. Here, this is somewhat important. This you might see definitely on your test and your exam, but this may also come up on the PSAT and SAT. This idea of an extended ratio. The main thing you're looking for here is what is the topic of the sentence. The measures of the angles in triangle ABC are the extended ratio. Find the measures of the angles. So we're talking about angles of a triangle. Well, what do you know about angles of a triangle? You know that a triangle has 3 angles. and they add up to 180 degrees. So we know that we have the measure of angle B plus the measure of angle C plus the measure of angle D. We know that that's going to add up to 180. Well, we have 2 times some number, and 3 times some number, and 4 times some number has to add up to that 180. When you have an extended ratio, that means it's reduced down into 2, 3, and 4. That means the angles might actually be 2, 3, and 4. But that doesn't add to 180, so that can't be the answer. Maybe it's twice that amount, 4, 6, and 8. Or 5 times that amount, 10, 15, and 20. Or 20 times that amount, 40, 60, and 80. Or 100 times that amount, 200, 300, 400. Whatever's going to add up to 180, they can get reduced down into this extended ratio. So here we're trying to figure it out. 2 times something plus 3 times something plus 4 times something. Total of 9x equals 180. Here we get x equals 20. So we know that the measure of angle B is going to be 2 times 20. The measure of angle C is going to be 3 times 20. And the measure of angle D is going to be 4 times 20. And together they add up to 180, and they can be reduced down to 2, 3, 4. Okay, here's the same idea. We're talking about an extended ratio with the 5 to 2. The perimeter of a rectangular table is 21 feet. So there's your rectangular table. The perimeter equals 21. The length to its width. Length comes first to the width. So this is your length, and this is your width. So your length is going to be 5 times the number, and your width is going to be 2 times the number. Well, if we're doing perimeter, we know that we're going to have another length and another width if we're going to actually add up to 21. Perimeter's all the way around. So we're going to have 2L plus 2W equals a perimeter. So we have 2 times our 5x plus 2 times our 2x equals our perimeter of 21. You could write it with the 4 terms, 5x plus 2x plus 5x plus 2x if you like. Or you can use your typical formula for perimeter of a parallelogram, which is twice the length plus twice the width. So here we get our 10x plus 4x. That's 14x. And we can divide by 14. 7 goes into 21 3 times. 7 goes into 14 2 times. So x is 3 over 2. And so if we're going to calculate our length is going to be 5 times 3 over 2. So 15 over 2. You could call that 7.5, and those are feet. Our width is 2 times 3 over 2. If you were to multiply those, you multiply just the top, so you get 6. over 2, which is 3. You can also think about it as a 2's crossing out, and you're left with a 3. So those would be your two measurements that have a perimeter of 21, because this adds up to 11.5, and 11.5 is 21. No, they don't. They add up to 10.5, and 10.5, that's 21. Okay? Just to be sure, check your work to be sure it's accurate. So if you have a ratio equal to a ratio, we name that as a proportion. So if you have a proportion, we can cross multiply to help solve a proportion. So that means the A is going to multiply the D, and the B is going to multiply the C. So we'll cross multiply. 4x equals 3 times 16 because we cross multiplied. That's 4x equals 48. X is going to be 12. So 2y is going to be 40. So y equals 20. Cross multiply. Now you got to watch this one. This is 9 times x minus 3 because it's 9 times that quantity. And then of course this is 3 times 2x. The reason why it's important if you have this binomial, the 9 has to multiply both terms. So 9x minus 27. So the parentheses are very important here. So I'm choosing to subtract the 9x to get negative 3x, and then that divides by negative 3 to get a value of 9. So if you plug 9 into here, we get 9 minus 3 is 6. 6 over 3 is 2. Put 9 into here, and we get 2 times 9 is 18. 9 goes into 18 2 times, so 2 equals 2. It worked. Here are some properties. Now these properties, some of these you may have seen before, but this is what really turns it into a 10th grade topic compared to that elementaries or definitely middle school when we were solving proportions back then. Now we're looking at some different properties of proportions for geometry class at a level of 10th grade. Typically geometry is. If two ratios are equal, then the reciprocals are equal. What that refers to is that if you have a proportion, let's call it 6 over 2, and we'll say that that equals 9 over 3, they both reduce to the number 3, or they both cross multiply to the number 18. So these are equivalent ratios. It says that we also would have another proportion if we took the reciprocals of these. So if we said 2 over 6 equals 3 over 9, that's also cross multiplying to become 18, or reducing to 1/2 and reducing, or 1/3, sorry, good point, and reducing to 1/3. 1/3 equals 1/3. That's a true statement. So that means these two ratios are equal. If you interchange the geometric mean. That's a little tricky. Geometric mean, not a term we use a lot. Geometric mean are typically these two values of your proportion. Mathematically, we can get away with it being either set, but it's typically those two values. So if 6 over 2 is going to equal 9 over 3, then we can interchange those. 6 over 9 equals 2 over 3. Let's see if it follows our same rules. This reduces down. 3 goes in here 2 times. 3 goes into there 3 times. So 2 over 3 equals 2 over 3. Well, that's true. Cross multiplying 18 equals 18. That's completely true. So you see that it's still equivalent to each other. On the flip side, here's our third property. In a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So that would look like if 6 over 2 was going to equal 9 over 3. It's just a true proportion that we know of. This talks about adding the denominator to the numerator. Take the 2 and add it to the 6, but still keep a proportion, so you have a fraction equals a fraction. Take the denominator and add it to the numerator, denominator and add it to the numerator. We have 8 over 2 and 12 over 3. 8 over 2 is a value of 4. 12 over 3 is a value of 4. 4 equals 4. It completely works. In this diagram, we have these proportions. Write for true proportions using this. Well, we know that we have the reciprocals. So we can flip these all over. We have the geometric mean. And that's when we interchange one of the cross multipliers. We have the add a value, specifically the denominator to the numerator. So AC plus DF has to equal DF. That's not because DF can cross off with DF. That is not true. That can't ever happen. And BC adds to EF. And it cannot cross off the EFs because of the plus. You can't drop that off. So that's another true proportion. Okay, and then to get our fourth one, we can often reduce, but in a geometric mean, you could actually reduce or interchange in the other direction. That would be a fourth way, or reducing. Reducing ratios is another way. We don't have numbers when we use the letters, but reducing would be a fourth way to have done that. Okay, we're going to solve. So we're going to plug in our numbers. DF makes 18. AC makes 12. EF makes X. And BC is 9. Now we could interchange. We could have written them in any of the formats here, and we would have still solved it and gotten the same exact answer. So we're going to cross multiply, and we're using the numbers that they have there. All right, just checking my work one more time. Okay, so my 9 times my 18. Well, if it was 10 times the 18, that'd be 180. But it's only 9 times that, so that's 18 off of 180. So 162. And 12 goes into 16 one time with 4 left over. Not quite what I was expecting. But we'll make this work. Okay, so 12 goes into 16 once with 4 left over. 12 goes into 42 3 times with 6 left. That's 36. So 0.5. So X EF is going to be 13.5. So don't be afraid if it has a decimal as an answer. You just look over your problem again and be sure you plugged in the right values, and then you solve it. You use the math you know. Here they're giving us what the proportion is going to be. JL. JL is a value we don't know. LH is the total distance of X. Notice that X goes all the way down to the bottom. JK is 15. And KG is 5. Cross multiply. And notice that we have our value of X here. We have our value of X, then we're going to need to we have two different unknowns. Let's see how this works out for us. JL times 5 and 15 times X. Divide by our 5, so JL is going to equal 3 times the X. Well, what we know about JL is X minus 2. We see that X is a total distance all the way down, not including this 2. So JL here is X minus 2. Aha, I see what I did goofy here. This is supposed to be LH, and LH is 2. You probably recognize that. Good eyes. So when we cross multiplied, we actually had 30 in that case. And we reduced that to get 6. Okay, so we now know what JL is, but we just talked about how JL is X minus 2. So X, which is JH, has to be 8. So where I had made my mistake first is that I wrote down an x value for LH, and LH was actually 2. I'd actually talked about how it was 2, but it wasn't making sense what we had, so I went back and checked my work, and lo and behold, there we go. Alright, last one. KL is 12, GH is our unknown, JK is our 15, and JG all the way through is our 15 plus our 5. Well, we cannot cross the 15s out. We actually have to add to get 20. If you would like to reduce and not work with such big numbers, you can divide both of these by 5. So we get 3 over 4. If you like to work with smaller numbers, then help yourself out. 48 equals 3 times GH. So GH is going to be 16. Good job, everybody.